Morning everybody, welcome to another edition of the Lab 207 webcast. My name is Mr. Kite and I'll be hanging out with you today as we continue on in our series on the origins of life. Topic for the day is going to be extinction and mass extinction. So as always, let me get you your objectives and we'll get going. By the end of today's video, you should be able to do the following. First, understand the role of plate tectonics in the evolution of life. Going to collide some geology and biology. Second thing, explain the importance of major mass extinctions. And finally, describe the role of adaptive radiation in evolution. So that's what we're going for. Let's start getting there. First thing, plate tectonics. Now, I know we are not taking a earth science class here, but they are kind of important. So the basic idea is that over time, the plates of the earth have moved and shifted because, well, the surface of the earth is kind of cracked like an egg. So over time, the plates on which the continents and the oceans shift have moved around into a bunch of different configurations. The idea is that at 3 different points in Earth's history, all of the plates were together in supercontinents. The one that everybody usually hears about is Pangaea. It was the most recent configuration. But in terms of evolution, the reason plate tectonics is important is because if animals are living all together on one giant supercontinent, as the plates split apart, different plates are going to get essentially a different allocation of animals. So it's like each set of animals gets stuck on a continental raft and then goes for a ride. And they have to adapt to wherever that plate goes. So for example, Antarctica at one point in time was up near the equator, so it was probably tropical. When those plates broke apart, whatever animals got stuck on the doomed raft of Antarctica that were adapted to a tropical environment had to, over time, adapt, or actually what happened is it became extinct because it moved to a polar environment. Also, when the plates were together, it is likely that the interior of the continent had a very harsh climate while the outsides had a not so harsh climate, and oceans were probably a lot deeper than they have been previously. So the Earth looked totally different, and animals had to adapt to those differences as the surface of the Earth changed around. Now, over time, there have been 5 major mass extinctions. If you look on our little chart over here, you can see what this shows is the number of families of animals going extinct over time. And the background extinction rate is pretty much kind of how things happen naturally in nature. Animals are always living or going extinct. But as you can see very clearly here, there have been 1, 2, 3, 4, 5 times where, for whatever reason, the extinction rate suddenly spiked and then fell back down. So this would look like a time where a ton of animals died off all at once, and then diversity built up and they died off again. Fossil record shows us that of all of the species that have ever lived on Earth, 99% of them are extinct. For the purpose of this video, I'm going to talk about 3 extinctions real quick. First one is the Permian Extinction, and during this extinction, 96% of marine species died. Thought is that it was due to a hot Earth and slow ocean currents. Now, what I mean by that is, the thought is that during this time in history, the area that is now Siberia was very volcanically active, which had a couple consequences. First of all, it's possible that a large chunk of Asia and Europe was covered under several hundred feet of lava. Obviously, it's hard to have life on top of a lava flow. But the other idea is that there was so much volcanic activity going on that there was a ton of carbon dioxide in the atmosphere, making the Earth roughly 6 degrees Celsius warmer than it is now, which would have had many effects, one of which would have been a slowing of ocean currents. As ocean currents slowed, oxygen levels dropped, which ended up suffocating most of the marine organisms. Also, it led to an anaerobic environment where some bacteria may have arisen that produced toxic hydrogen sulfide that may have leaked into the atmosphere and then poisoned many of the animals living on the surface of the Earth. So that is the Permian Extinction. The next one is the one that most people know about. That is the Cretaceous Extinction, and this is the one that took out the dinosaurs. The leading hypothesis on what happened this time is that a giant meteorite struck the surface of the Earth. Support for that idea is twofold. One, there's a giant crater off the Yucatan Peninsula in Mexico that is about the size of a meteorite that would have taken out most of life on Earth. The second thing is, around the world, in fossil layers or in rock layers, there is a thin layer of sediment that contains the element iridium. Iridium is not common at all naturally on Earth. However, it is very common in meteorites that strike the Earth on occasion. So the idea is that a meteorite struck the Earth and it sent all of this iridium sediment into the atmosphere that spread around the Earth and settled as this fine layer of dust that had iridium in it. So the idea was that during the Cretaceous extinction, most of the dinosaurs were taken out. And many scientists are pretty sure that a sixth mass extinction is presently underway. Now, fossil record shows us the past mass extinctions. It shows times where a ton of animals have gone extinct all at once. Obviously, if we are sitting in the middle of this mass extinction right now, we don't know what it looks like in geologic history, but scientists are pretty sure that presently animals are going extinct anywhere from 100 to 1,000 times faster than they normally would. Obviously, or I guess not obviously, but the hypothesized cause for that is human activity, whether it's habitat destruction like you see there on the right or human-induced climate change. Either way, we know that animals are going extinct much faster than they normally would, and it is likely because of human destruction of habitats, pollution, global warming, things like that. Now, as far as extinctions are concerned, it means new opportunities for animals that would have been oppressed or marginalized. So, for example, during the Cretaceous extinction, during that period on Earth, dinosaurs were the ruling organisms of the time. And there were probably some small mammals, but they would not have been big enough or hardy enough to compete with the dinosaurs that were present at the time. So the dinosaurs would have been the ruling class, if you will, and the mammals would have been marginalized. However, if in that great extinction event the dinosaurs, the major competitors of the mammals, were taken out, that would have provided opportunity for mammals to diversify and radiate and take over the Earth. So usually an extinction means a mass extinction event means the fall of one type of organism, allowing another type of organism to arise and diversify. And that leads me to the idea of adaptive radiation. If you remember back, adaptive radiation is basically the idea that animals start in one place and then diversify to fill the niches around them. So this would look like you have species A here, and then there are a ton of niches around it. And as species A moves and diversifies to fill these niches, you get species B, C, D, E, and F. So if we go with the idea of taking out a dominant species, if you get rid of something like a dinosaur, suddenly there are a ton of niches available, and the mammals living in the area can now diversify to fill those niches. Also, if you think about continental drift again, as one continent breaks away from another, animals will fill the niches in that environment. One example of this would be marsupials in Australia. There are marsupials around the world, but they are most common and most dominant in Australia. So the thought is that as the land masses broke up, the landmass that became the island of Australia had the marsupials on it, and as that landmass moved away and kind of became its own area, the marsupials diversified and filled out that continent. Another idea on this is Hawaii. Hawaii is like 3,000 miles from the nearest landmass, and so it's also a series of volcanic islands. So any species that is there probably came as a refugee on ocean currents or was carried there by people or something like that. So most of the species in Hawaii are unique because one parent species would land and then it would diversify to fill out the niches of the island. So hopefully that this little primer on extinctions has helped you to kind of get your head around what the history of life on Earth may have been like. Animals rise, animals fall, and when one group of animal falls, gives a chance for another one to take its place. So thanks for joining us on the Lab 207 webcast. My name is Mr. Kite, and hopefully we will see you again.